Hey, everybody. Welcome to Open Network User Group Podcast. I'm Mark Tierney, ONUG CTO. Listen up. Integrating public and private networking, it's become a top priority for enterprises as they seek to optimize their network infrastructure and adapt to the evolving digital landscape. But this integration journey, is it a journey or a challenge? I don't know. It's tough. But what is tough about it? You might ask. Network complexity, security, and compliance. Interoperability is always an issue, performance, QoS, scalability, cost management, like the usual stuff, right? And overcoming all those challenges requires a significant strategic approach. Who do you collaborate with and why, who your technology partners are, and can you trust them, right? So we're going to dive into this topic today with some really incredible guests I'll introduce in a moment. And we'll figure out if you've got what you need in your enterprise to achieve your digital transformation goals. All right. But first, ONUG Fall 2023 is going to be here before you know it. New York City. That's where it's at the Chelsea Industrial Event Center. It's October 24th and 25th. Join the ONUG community of global 2,000 companies, tech execs, enterprise architects, infrastructure engineers, cloud providers, thought leaders. You got it. They'll all be there, and we'll discuss and demonstrate the tenets of enterprise cloud networking, security, policy. Policy is a big deal. Go to onug.net to register for this event today. Use promo code ONUG podcast, and we'll give you a truckload of savings on a 20% discount. Don't forget to share, like, subscribe, all the things that you do on your platform. Do that for us so we get the word out. We're going to have a really good discussion. And having that discussion with me are, again, two really bright people from AWS. Nick Coval. Nick is Principal GTM Specialist in Global Connectivity at AWS. And Seejo Sebastine, he's AWS's Global Head of Connectivity and Business Development. All right. So after all that blathering I've done, let's talk about it. So you both know I've sat on the consumer side of this equation for quite a while, and this emergent trend, particularly the trend of bringing together public and private networking, integrating all that together. There's a lot of challenges, and let's start with what are you seeing today as the enterprise's biggest challenge in bringing together the public and private networking space? Who wants to start? Nick, you want to go?
Sure. Well, thanks, Mark. Appreciate you guys having us here today. Excited to talk about global connectivity. Like, this is our bread and butter. We love working with customers, helping them achieve their hybrid connectivity goals. And you hit the nail right on the head. When we talk about hybrid connectivity, we're talking about how you connect these public clouds, the public networks, and your private on-premise networks. And the challenge customers have is that there's different technologies on either end of the spectrum, right? On-prem, you have a different set of, you have products from similar vendors, but they look and smell differently. There's different skill sets, the people that run them and operate them. And when you get to the cloud, it's like a completely different ballgame, right? And so, like, typically we help customers in the journey. We take small steps, and largely customers often experiment in the cloud with compute because it's the easiest thing to get started, and you can start building really rapidly and quickly. And then customers often start their connectivity journey by using easy to put together VPN services, right? And there's native VPN services that come built into most of the clouds or all the clouds. And then there's also, depending on how much of a relationship or experience they have with individual third-party vendors, they often offer VPN or SD-WAN type of solutions. That's typically where customers start. And then as their journey goes and more workloads get moved to the cloud, they then see the need for greater reliability connections, like dedicated on-ramps, like Direct Connect and AWS, for example. They offer high speed, low latency, low loss, really high speed connectivity. And then it just goes from there. Once your presence goes beyond an individual location and you have multi-region presences and you span country borders, then it's a whole nother level of complexity. But once you get there, if you build the foundations right with those foundational services that we talked about, there's services that you can put on top of that make it easy to connect kind of across the globe.
So one of the things that always jumps out at me about this is complex, not complex, hybrid, not hybrid, in-house, out of the, out of your, out of your data center. I would argue that, most enterprises, are willing to tackle just about anything if I'm, hitting those pillars of, cost, performance, improved security, whatever it is. But, there's an observability story around all that. And, are you hearing that, Seejo? How big of a play is observability in the enterprise today when I'm moving my, whether, it's networking for my compute or networking for, cloud connectivity, whatever it is that drumbeat out there as much as I believe it is?
Yeah, I mean, I'd say the answer is yes. I mean, the short answer is yes, Mark. And I think it's probably beneficial for us to think about why enterprises are going through this journey. I mean, ultimately, it all sort of boils down to the age-old question, right, of build versus buy, right? You can continue to build things yourself and then use the cloud as an extension of your network. Or over time, as obviously your applications have migrated from that model of building things in-house and running it in your data centers, and they're migrated to this model where everything's built in the cloud and you're essentially buying and consuming them as a service. So as as CTOs and senior executives in our customers, they grapple with this decision of like, how much do I want to be part of that transition? Am I at the forefront of it? Am I kind of fast follower? What we see is that almost everyone starts to make that decision by working towards consuming small applications, applications that probably are used by different business lines of business, and moving them into the cloud. And as they're doing that, obviously the network that supports that comes along with it. Nick, did a great job of just talking through the various options that are available. Now, as they've gone through that process, they obviously are also grappling with the control that they had when they were building and running and operating everything themselves. And it's a common challenge that we see, and obviously our customers ask us all the time, is I am now treating my network as a black box. How can I be sure that when the proverbial hits the fan, I have the levers necessary to make sure that I know what's going on? What can you give me that's just as good or better than what I already have? And that is a common challenge that we're seeing. I think across all of the CSPs, there's more that we can do to make sure that it does not appear as a black box to our end customers, and that we give them the necessary tools to provide the visibility and the observability that they desire. But I think over time, as the level of comfort increases with looking at the network as not something that you operate, but something that you buy and consume, observability, at least as we traditionally know it, is probably not going to be top of mind, or at least not a major consideration over time.
It's interesting that you brought it up the way you discussed it the way you did. A topic that is being hit hard for ONUG members these days is kind of the resurgence, if you will, of the network engineer, and the NOC engineer, and their role in cloud management. Particularly from the perspective, and you brought up, something hits the fan, right? Who do you call? Right. And, there were these, maybe in the early days of cloud, there was this idea that you got a DevOps person, a dev net ops person, a net DevOps, whatever you wanted to label it. Right. But, at the end of the day, when you're concerned about the reliability and the performance of your most important apps, sometimes you need that network engineer of old that can get in there and see what's happening on the network. So, I feel like the observability issue is still critical, and having the right tooling, or having the right window into what's happening in the networking space is just paramount for today's enterprise. It kind of begs the question, though. There's a scale issue, to scale and performance in all of that. Are you what's your take on what enterprises are asking for from a scale perspective? And again, when I look at it, I tend to look at these things from a cost perspective. When you say build versus buy, I might be willing to build that thing, but now I'm looking at the step function associated with infrastructure and standing it all up, and then waiting to fill up bandwidth. For example, do I really want to do all that? That's got to be an important message, I would think, from your vantage point on the enterprise not necessarily needing to do that. Is that true, or am I missing the mark on scale and cost?
Well, what I can say is our customers often come to the cloud for scale. So if you think about it this way, if you're running an enterprise in a traditional on-premise environment and you deployed your infrastructure, your compute, your network, your storage, all that, and you have your system running smooth, and you don't have a need for scale, meaning your demand is relatively stable, then you may not need to go to the cloud. But as businesses grow and the business demand drives the network demand, basically bandwidth demand on the network, there's the need for more infrastructure to support that. And that's where customers are looking to do that scale in the cloud, because you can scale almost instantaneously and without the upfront investment in the infrastructure. So I would say that the predominant reason or primary reason that customers are moving to the cloud is because of scale. The cloud, the benefits of the cloud are all about scale. You can run the smallest workloads with a single CPU instance, or you can run dozens of workloads with thousands of instances, and you can spin them up in a matter of minutes. And those are the types of things you just can't do on-prem. The other thing is you may be expecting or forecasting some sort of future event, right? In the network world, this is like seasonality. We're going to have some sort of event that's correlated to a holiday, and a bunch of people are going to go to a location and they're going to hit a bunch of buttons, or they're going to click on their phones and the traffic is going to skyrocket, right? How do we handle that? Like before the cloud, what you had to do is you had to pre-procure that infrastructure. You had to stand up, new switches, new routers, you had to order new circuits. And with the cloud, you can offload that burstability. So even if you don't have a necessarily demand or a reason to scale your infrastructure beyond your normal demand, if you have an event that comes up, especially if you're a seasonal business, offloading that to the cloud is a natural use case, because the scale.
So we're just talking about bandwidth. This is a bandwidth on demand kind of play. Is that what we're talking about here?
Yeah. I mean, if you look at like the retail industry, and they're a very good example of like seasonality, and because they have brick and mortar facilities that take customers, and for certain events around holidays in the year, Black Friday being one of the biggest ones here in the U.S., their volume on that day is greater than like the volume in multiple quarters of the year. So because of that, they just have to prepare for that. And if they were to expand all of their infrastructure to support that burstability on that day, it'd be a significant investment. And like most of the time, it would have low utilization. So that's why customers will find ways to burst into the cloud, right? And that might be your workloads are running on-prem and in the cloud, or you're using some sort of load balance ability to run it across. But the network is the foundation, as we all know, is the foundational like pipeline that keeps all the applications running on top. And when you got to run more apps, or if you run more users through the apps, you need more bandwidth. And ultimately, bandwidth at the end of the day in the cloud is just more compute infrastructure running bits, right? We just the cloud providers, we just abstract all of that infrastructure on behalf of the enterprises. So instead of adding more switches to the data center, they just click the button and then more infrastructure spins up.
I mean, to the point, I think you were also trying to raise, Mark, around costs, right? It would, I guess if we were to look at it again from the perspective of the buyers of network infrastructure, historically, they were buying racks of switches and routers and building that and having to go procure the licenses and then scale that licensing to accommodate for the worst case. Obviously, with the flexibility, literally, like I think this was a pipe dream of mine when I first started in networking. What if I could just turn up a network, using a programmable API call? Like that's a possibility today. Not only can you turn it up for 5 megabits per second, you can turn it up for 100 megabits per second or 100 gigabits per second. It is available. And the ability to do that and the models for applications that enables is really where that innovation is, right? We've talked to a number of folks, some in like healthcare, who really are looking at how they can basically stand up temporary networks. Right? You called it bandwidth on demand. It's just the ability to turn things up and down as they need it. They turn it up for a week while they're running a project. They bring data into the cloud. They process it, get a result, and then spit that result back out, and then turn the network back down. They don't need that capacity, so they're not holding on to it. That is such a fundamental shift from where we were, even 5 years ago. It was not a possibility. And I'm glad to see that that's the direction that we're able to enable through the cloud, and as well as through this pay-as-you-go consumption model that obviously is a big part of enabling that for our customers.
So are enterprises doing something differently then to be able to consume services like that? Is it what's easier, what's harder? How are they architecting and engineering differently in support or preparation for that? Are there, is there a flag that you can wave that says, "Hey, look at this. You could do this now. You could take that yoke off your shoulders because it's that much easier." What from the enterprise network engineer architect's perspective, what's easier for them? What are they doing a lot less of today?
I mean, I'd say that I think if you really just look at the stakeholders in the consumption of the network, then historically the stakeholders were application developers. They would go to the network engineers, and the network engineers were the be-all, end-all of it. Right, they would need to forecast, determine what the network looked like over time. To Nick's example, in specific times of years, et cetera, and build for that worst case. But now, application developers, with microservices and the new architectures that exist for application development, application developers are sort of the main stakeholder, right? They want to be able to go turn up a microservice that communicates across different regions, because they want to support some new initiative that's in Europe for headquarters being in the United States. It's use cases that, again, that we would have loved to support in the past, but just weren't practical, and they're very much more so practical at this point in time. But we've also seen a number of our customers really take that to a new level, right? They've sort of built centers of excellence because they've determined that the complexity obviously has gone up in terms of running a network that's hybrid, both on premises and in the cloud. And they almost function as a as a center of excellence or a support for the application developers. Application developers, all they need to know is, look, I can instantiate my network connectivity by this API call, and the rest of it, that infrastructure that obviously spans on premises and the cloud, is just handled by specific teams whose dedicated function it is to get that done for their organizations. So it's also sort of changed the model of operation from just the network engineer having to determine everything, to one where they basically are reacting to demand, right? There's demand coming in, and then they have the tools at their disposal, especially with the cloud, to go turn up and react to that demand and deliver essentially a service, network as a service, when they need it.
All right, Nick. So obviously Seejo, he just wants to give it all back to the developers, right? Because it's all going to work great.
They make the world go round, man. They build these apps. I mean,
they do.
These guys do.
They do. But the only thing I'm pushing back on is and that's the way it should work. Like I 100% agree with all that. But as a practical matter, again, I'm just sort of reinforcing this idea that we're hearing from our members is that the network engineer and architect is reemergent, right? Because of complexity, things do go wrong, right? And when things go wrong, who do you call on? a network person, right?
It's
We all know
right?
it's a network problem. We all know that, right? We knew it was a network problem to begin with.
Starts there at least.
I am a little curious about the ease of standing up infrastructure like this, because let's be honest, it's so much easier, right? But there are some things that we need to pay attention to, right? Security policy, things like that. What's happening in this space, and I like on the behalf of our members, like to think about where are the gaps, like but let's start with just general security and policy. Are there things that we need to be thinking about differently as we stand up infrastructure? What advice would you give to the enterprise from a policy and security standpoint, Nick?
From a security perspective, you need to strongly consider zero trust principles as you are building your networks today. If you're transforming networks, as in from the enterprise, and you're connecting to the cloud or migrating to the cloud, in today's day and age, there's a lot more available tools and services to help us build on zero trust principles. And at a really high level, if you think about back 5-10 years ago, the network architects were focused on providing connectivity between entities, right? We would build VPNs, we would stand up VLANs, we would establish routing so that a set of hosts on one subnet can talk to a set of hosts on the other subnet, right? And that's kind of how networking doesn't work anymore, because that's a real big risk. What that means is your attack surface is large. If I have a subnet with 10 devices over here and 10 devices over there, and they can all talk to each other, it just takes one of them to get compromised, and then they all go down. So zero trust principles is really at the core of how architects and network engineers are designing networks today. So they're using services that require devices, people, and other machines to authenticate before accessing resources. So you still need IP addressing and you still need routing. But before connectivity crosses a layer 7 boundary and a connection is established, like a TCP connection, it goes through a broker. And that's where your zero trust is enforced, so that each connection can be authenticated at the most granular level. You can do it at the connection level, right? You can do it at the host level to be, as you start to develop and get into zero trust, that's a little bit easier. But once you get down to the session level and you can have user authentication per session, that's how you reduce your attack surface the most. And in network security, that's really what you want to do. If you're designing your network, trying to make it as secure as you can, that methodology is just reducing the attack surface. It's reducing the amount of surface that any individual entity, device, IP address, machine can reach unless it's authenticated. So if by default you don't allow anything to talk to anything, then that's pretty much as secure as you can get, right? Security our systems are most secure when nothing can talk to each other. Now, obviously we need connectivity for applications to work. And so you start enabling communication and connectivity where it is, and that's when you can now ensure that when connectivity is established, that it's secure. And we actually have, AWS is innovating in a bunch of services in this space. We have a VPN-less remote access service now where you can connect to private workloads without using VPNs. And inside AWS, when you're building access to applications or between applications, you can now use VPC Lattice, which is a completely different technology that doesn't require learning or knowing IP addresses or routing. It literally works at layer 4 and above. And you can facilitate connectivity between applications, machines, users, all of that by using this new service so that you can develop connectivity and build it within the cloud, within AWS and across, to your other clouds or other on-prem devices by using these zero trust principles and basing your connectivity on policy.
All right, so let's unpack that a little bit. If I can go to another level of detail, you threw me on that because I was about to say, there's no such thing as just scaling bandwidth, right? I mean, in the network space, and I ran perimeter security for a large multinational financial firm at one point, right? And so it's not just the bandwidth side, right? It's okay. Now, what's the capacity of my my firewall infrastructure, my intrusion, IDS, IPS, stuff. Like everything's got to scale, right?
Mm-hmm. Yeah.
So how do architects and engineers need to think about that in this context? Are you suggesting that this new technology makes all that go away? I wave a magic wand, I twitch my nose, and I don't need to worry about IDS, IPS firewall stuff anymore, or what do I need to be thinking about here in that space?
So,
Because everything's got to grow on demand, right? IDS, IPS, firewall, like you tell me.
So in the context of let's just generalize this as deep packet inspection, right? It could be a firewall, it could be IDS. People have different names for these things, right? But if you feel the need to tear open packets, right? That fundamentally should be done when you don't trust the traffic, when the traffic is not trusted between two endpoints. In the zero trust world, if you establish that connectivity can happen once trust is established and then authentication is occurring, you don't need those inspection technologies, right? But we all know we're not going to be all in zero trust tomorrow, or today even, right? Or tomorrow. So you have to use your inspection technologies like those deep packet inspection, the firewalls. You have to use them carefully because they are costly, right? The inspection technologies cost a lot,
and they have to scale.
Yeah, and you're right. And so those technologies are challenging to scale unless you have it built into a native service, right? Think about putting VMs on load balancers and making sure that they're all talking and you have shared state, and that when one connection comes in on one firewall, it hits the other one. Like in the cloud, that's all automatically scaled as a complete native service, right? That's the advantage of the cloud. That infrastructure for the compute of all of those inspection of all those packets, the memory, the storage, and then the bandwidth that goes between them, the amount of instances you need, that's all elastic. Now, when you put the components together and you have a workload and some sort of routing infrastructure and an inspection infrastructure, you do need to make sure that you have the right types of attachments, like you attach the right services with the right sizes to each other, because you can create bottlenecks and constraints. So the architects today have to really look at regional bottlenecks. So when they're built, so the bottlenecks within a singular region, right? When you're building workloads within a data center, for example, is less of a concern. But as soon as you have to cross availability zones or data centers or regions, those are where bottlenecks become most apparent. And that's where latency gets introduced, right? So you want to reduce the amount of latency you're injecting, and you want to reduce the amount of movement that you have. But you have to be very careful about how much you use inspection. And with the newer services that are trust-based from the beginning, you have to do less inspection. But when you do have to deploy inspection, it's typically, like you said, in a perimeter fashion. It's on the edge of the trusted network, on the boundary between the private and the public network. That's the most common place where customers are deploying these inspection technologies. That's where you get your biggest bang for your buck.
Yeah, and just in case it sounded like that was a gotcha question. I mean, I'm saying this for the perspective of I don't even know what a firewall is anymore, right? I don't.
Yeah.
Right.
They all look
it's getting
the same.
Right. We don't have any. We have 1,000. The answer's somewhere in the middle there, and I don't even know what it looks like. So,
Mark, just from the scale perspective, right? I think you're also trying to drive towards the scale of, say, for example, firewalls. And I think where Nick was going was basically outlining that within the cloud, scaling is kind of like a ground zero function. It is built into how you build or architect a network in the cloud. We provide services such as gateway load balancer, where you can take a firewall that say comes from Palo Alto or Fortinet, and just operate that at scale just by using that underlying container as a gateway load balancer, which allows you to load balance the traffic without having to worry about how it's done. It's just handled within the service itself. So that sort of becomes a fundamental construct, if you will. And it doesn't mean that we're disregarding the need to scale. We're just saying it's just making it easier for you to determine when you have to scale and how you scale that up. And we make that easier within the cloud.
Okay, that's fair. I'm sorry, my brain goes here every time I start thinking about deep packet inspection. We start thinking about compliance and governance things too. I mean, the world's changing, right? How we behave, what we do with our data now depends on where our data is moving through, where our data resides. Right? GDPR being the obvious scenario. I'm sure there's others that are top of mind. How does or how is these new emergent technology networking trends impacted by that, and what do network architects need to be thinking about when it comes to data locality?
That's a great question, Mark. I think if you look at it through the perspective of the need to drive towards the data residency or satisfy the data residency requirements, and trade that off against the complexity of an architecture that essentially it has a per region or per geo specific network. That's sort of the trade-off that we see a lot of our customers making. So where regulation clearly dictates that you must keep data in country, we see a lot of our customers gravitating obviously towards services such as local zones, or just using outposts to make sure that you can essentially extend an arm of the cloud into your data center, your co-location facility, or a local zone if we've delivered that. We also see sometimes where that data residency, but for the purposes of cost, is kind of driven all the way down to the edge, like to the customer endpoint location. Services that allow you to run that down in the branch or in a location where you're optimizing for lowering your cost while still maintaining the data residency requirements. So you don't necessarily need to upload everything to the cloud just to process it and then bring it back down. You can run a lot of that at the edge, if you will. And the definition of that edge really varies based on the customer. There's really no one size fits all model for that. But at the end of the day, the ability to build an architected network that delivers on the data residency requirements is one that we will continue to strive to support, because that is a constant refrain that we hear from our customers, especially from a regulation standpoint. Nick, do you want to add anything there?
No, but I will say, like, from a network perspective, there's two aspects of that. There's managing the data at rest and then managing data in transit. And so, like, on the network side, we're primarily focused on that transit piece, and it's less you need to pay more attention to, for example, data in transit that's being inspected is a network data residency challenge, right? Sometimes when data is traversing points but not being stored at rest or not being inspected, depending on the regulation, you have more flexibility. So deploying IDS and IPS that break open encrypted streams raise the eyebrows for people who are trying to ensure compliance to certain regulatory frameworks, like in the US, PCI, for example, right? It's a regulation that tries to enforce best practices around where and when and how you do certain things and inspect traffic and break things apart. So the less you can do that, the easier it is to comply with a lot of these governance structures, right? So if you're, by the way, this is kind of like another push for like zero trust, but as you use more zero trust principles, you rely less on those technologies that require more regulatory scrutiny. So that's another way to look at it from the network perspective. The more authentication-based access you can provide, the less big middle boxes you have to deploy, and the less compliance audits you have to worry
All right, that's great. We're running down the end of this, and anybody who knows me, anybody who's listened to me pod, it knows that I tend to look at any service, anything I'm going to buy. It better be hitting hard on one of 5 pillars: cost, security, time to market, customer experience, or eliminating technical debt. I mean, these are things that are paramount to me and to most enterprises. We've talked a little bit, Nick and Seejo, about the the value of on-demand networking from a sort of periodic event basis, right? Like the thing that happens every now and then, right? But I haven't heard us talk anything about just time to market in general. Like I'm standing up a new service, and I need to stand it up fast, right? And maybe that's the same thing. Maybe it doesn't matter. But out of those 5 things: cost, security, time to market, customer experience, technical debt, those are the conversations that you have to have with, not your advocates on the inside. They know, right? Your network architect, those people, they get it. Like they know. But you got to have that conversation with, the chief financial officer, whoever is going to say, yes, we're going to go with this service. What out of those things do you feel like the enterprise should be beating the drum about to implement this type of new networking functionality? What do you really hang your hat on the most out of those 5 things: cost, security, time to market, customer experience, technical debt? Any one or 2 of those things that's most important, Seejo?
I mean, I'd say the top 2, and AWS always kind of works backwards from customers. So if you're a stakeholder internally that is reviewing this sort of transformation of your network, I would hope and expect that you are looking at the customer experience, the customer benefit of doing that, certainly to start. But also as a sort of force multiplier for your business. The expectation, hopefully, is that you're also looking at how that's accelerating your business, right? Adding agility to your business, so the time to market aspect, as you said. But I don't think we can disregard the others, right? You can't. It's not a trade-off that's easy to make, where you increase your time to market, but at the cost of security. That doesn't happen. Or if you're going to pay a whole lot more, it's not happening. So I mean, I think everything is important, but you've got to start the conversation somewhere. And I think most of these conversations start by, look, I can make this better for our customers, and we can potentially expand our market or get to customers faster, deliver things a little bit quicker and in a more agile way. So I think those is where I would start, but I don't think you can ignore the rest.
Part of my charm is putting you on the spot, so you're
yeah, I
so
mean,
you're
like,
right.
Just consider like the macroeconomic conditions we're under right now, and probably most IT leaders that are watching this particular podcast have a smaller budget than they did 12 months ago, right? So in that particular context, cost is probably the most scrutinized of those 5 right now, because it's what drives the bottom line, right? And you can't sacrifice security, but what we try to help customers do is optimize their costs, right? And there's been a lot of focus from customers on trying to how to optimize their costs these days. And so if you're in the network space, as we all are, right, one of the first places to look is, do you have the opportunity to identify links in your network that aren't highly utilized? And if you have those links that aren't highly utilized, consider replacing them with some sort of on-demand service, right? Like a cloud connectivity service. And the farther the distance of those links that are lower utilized, the higher the ROI is to use a cloud-based consumption model service. Now, if you're running like 100 gig waves across the US and they're 90% utilization, you're likely not going to replace that with like a cloud backbone. But if you have like 1 to 10 gig connections and you're running like 10% utilization, there's probably a good opportunity for you to reduce your costs there and eliminate the need for your fixed investment. Like once that investment's amortized, consider looking at using like a cloud connectivity service to replace that. And I mean, that's like in today's context of like cost being top of mind, you could argue that the cloud is more secure. So if you're transitioning from some non-cloud-based service to a cloud-based service, there's often more opportunities to increase security. That's kind of what I would say in the current macro conditions. A lot of customers are asking us, like, how can they reduce costs? How can they save money?
Amen. I agree with that 100%. Having sat in that seat on the inside from a network engineering perspective, those pressures are always there. They're not going anywhere. My recommendation to, my old peers in that space is start with cost and go, and oh, by the way, I'm going to improve your time to market. I'm going to improve your customer experience. But you're not getting past the CFO's, question of, are you driving my cost down, or are you getting me more for the same or getting me more for less? If you can't have that conversation in a network space, you're probably not going to get very far. That's been my experience. Okay. You guys have been great in spending time talking about things in the general. I'll give you a couple minutes, to toot your horn. What's going on with AWS specifically? What do you want customers or potential customers to know about AWS networking?
I mean, I think we referenced quite a few of those things as we were chatting. Nick alluded to services that we've continued to release at scale that simplify what networking means, both to network operators as well as all the way to developers. Right? VPC Lattice is a service that we just released a few months ago, and prior to that, our kind of foray into Zero Trust with AWS, we call it AVA, Verified Access is the service. About last year, we also released services that help our customers either to build networks that scale through the use of the cloud as that mechanism. So essentially building backbones in the cloud without having to run and operate that themselves. Those are services like Cloud WAN, as well as Direct Connect Sitelink. And obviously, we're happy to share more information on any of these services if they're of interest to any of the audience.
What's the best way to engage with AWS from a networking perspective? Where do you want people to go?
I mean, obviously, we'd definitely encourage people to go to our web pages, our product pages. We provide all the detail on the product pages. We do have the ability for anyone that's interested in our services to reach out to us, to our sales teams, as well as the go-to-market and business development teams. Obviously, we're available if someone wants to pick up the phone or send out an email and reach out to us and have a discussion, engage. We're always happy to do that. We're always looking for how we can help our customers do better with what we're bringing to the market, both currently as well as in the future.
That's great. Listen, what's that?
Easiest way to get us is hit us up on LinkedIn. We're always on there.
All right, nice. All right, perfect. Seejo, Nick, thank you so much for joining us today. Just shout out to everybody. Thanks to all our listeners for being here today to join Seejo and Nick to talk about these topics. It's certainly crazy stuff, and we're addressing crazy stuff at ONUG. Join the ONUG Collaborative, and you can find out more about these types of technologies, specifically the Network Cloud Working Group. Great place to start. Our Hyper Automation Working Group. We are about to stand up a private 5G enterprise 5G working group. There's a lot of ways to get involved, so do that. You go to onug.net to figure out and find out where to connect with your community around all these networking topics. On behalf of the ONUG community, thanks for joining us today. We'll see you on the next ONUG podcast. Thanks, Nick, and thanks, Seejo.
Thanks, Mark. Thanks for having us, Mark.